Okay, hello Year 12. We're still moving through the exponentials and logarithmic functions topic, but we're moving on today to 5E, applications of integration. So if you have not finished the previous parts involving integration and differentiation, you will need to go and work through 5A down through to 5E because you won't be able to do this otherwise. Okay, applications of integration. Now, all the normal methods that we have previously discussed can be applied to functions involving e to the x. Okay, so the rules that we've used before are going to work now. And that rule we're going to look at now is the area between two curves. We're going to recall that the area between two curves is given by this expression. Okay, so if there are two functions, one called f of x and one called g of x, if f of x is always above g of x in the interval that we're looking at, in this case our interval is between b and a, so written like this, so we've got an upper and lower bound up here, then we can straight up, if we know that f of x is always above g of x, just do a quick subtraction of the two functions. It works out nice and easily doing it this way. We get two functions underneath the integral sign, grouping together like terms of those functions, and it just makes it a lot neater. Okay, so that's something that we can do. Let's have a look at the example down here. This example is already put together the two curves, and our curves are e to the x and e. But what we want to do here is sketch y equals e to the x minus e, showing the intercepts and the asymptotes. Once we've done that, we're going to find the area of the region between the curve, the x-axis and the y-axis. But step one, let's have a look at that curve. I think that we as a class should be able to understand what that curve looks like without having to draw it to start with. So we all know what y equals e to the x looks like, okay, don't we? So I've just jumped into Desmos here and I've plotted y equals e to the x. This is what y equals e to the x looks like. And what we want to do with this graph is we want to translate that graph down by units that are of the amount e. So we know e is approximately 2.7. So what we're going to do is move this graph down e amounts. So down 1, 2.7. So our graph's going to slide down, and I will put that graph in for us. So that's what that graph's going to end up looking like. We're going to move it from up here, translating it down about 2.7 units, or better still, e units. And that's what we're going to be working with today. Okay, but we don't have Desmos in our exams, do we? So we need to be able to draw this without our Desmos to help us out. So that's there to back us up at home, but now we know what it looks like, see if we can draw that for ourselves. So this is showing the intercept. So when we're sketching, let's always look at the y-intercept and the x-intercept, okay? So the y-intercept happens when x is equal to 0. So let's pop x equals to 0 in there. So y equals e to the 0 minus e. So our y-intercept happens at e to the 0 is 1, 1 minus e. So at 0, 1 minus e, that's our point for the y-intercept. And back in Desmos, that was the point, we have a look, that we'd moved it down by. Okay, we've moved it down here. That's our y-intercept. Okay, now let's look at our x-intercept. When does our x-intercept happen? Our x-intercept happens when y is equal to 0. So let's pop y equal to 0 equals e to the x minus e. Okay, so in this case, what I would do with this one is I'd take my e to the other side, so I end up with plussing e to both sides, and I'll get e equals e to the x. This one's a little bit different than what we've seen. We just want to equate powers. So e here is e to the 1. So e to the 1 equals e to the x. So that implies that x must equal 1. So our x-intercept happens at 1 and 0. And if I jump back into Desmos and show you, yep, the graph hits there at 1, 0. So we now have this point here, and we have this point here. So we're nearly there to draw our graph. However, there's something else we need to think about. With it being an exponential, e to the x had an asymptote where? E to the x has an asymptote, which is the x-axis, isn't it? an asymptote at y equals 0, which is the x-axis. And what we've done with our graph is we have moved our e to the x down by e units. So our new asymptote is where? Where do you think that's going to be? Our new asymptote was at y equals 0, which is the x-axis, and it's moved down e units. So our new asymptote is y is equal to minus e, which is approximately y is equal to 2.718. So we've answered part A here in that we've looked at e to the x minus e, we've looked at the intercepts and the asymptotes, and now we need to sketch that graph for us. So let's pop that graph in there for us. Just fix up our screen. So you can quickly plot that over to the right if you've got some space. Okay, so we know that we were going through 1 here. We know that we were going through 1 minus e. If you're not sure what that value is, let's just pop it in there, but it's 1 minus our e, which is minus 1.71. So we're down here at 1 minus e. That's 1 minus e if that's 1. So it's a little bit past it. It's moved down. It's going to move along like that. Oops. Put that one up there. And we have a new asymptote, which is e. And we can dot that one out there like that. That's a sketch of our graph there. Okay, part B wants us to find the area of the region between the curve, the x-axis, and the y-axis. So I'm going to just move back over to my graph over here. So between our curve, which is here, our x-axis and our y-axis. So I'll colour in that area that we want to find. We want to find in here. So if we find the area under that curve, which is e to the x minus e, between the values of 1 and 0, that will give us the answer that we need. Okay, so let's integrate that. Because we've got an upper and lower limit, when we do integrate, we don't need our plus c, but we need to pop our square brackets and our upper and lower limits in there to substitute in. When we're integrating e to the x, we end up with e to the x. And that's what we've been doing for a little while now. But the next part, something we haven't actually particularly looked at. Now this e here, it's not e to the x. It's not a variable. It's not a function. It doesn't have an unknown or an x in there. It's e to the 1. And e to the 1 is a constant. So we are integrating a number. So think of what it was. If we were integrating 2, we'd end up with 2x. So what we have to end up here is we need to end up with ex. Okay, because e doesn't have the x up there, we need to pretend it's a number or a constant, and we are going to integrate that, and we're going to get an x after it when we integrate. Sorry, I've just lost that there. So let's pop in our value of 1 to start with. We're going to end up with e to the 1 minus e, because 1 goes in here and here. That's our first part. Minus, let's pop 0 in. Make sure you pop your minus, and I'd pop brackets in there, okay? Then e to the 0 minus 0. Okay, let's neaten that up. What do we get? E to the 1 is e minus 0. Oh, sorry, e. So e minus e is nothing. Minus, what have we got in here? 1. Okay, which is equal to minus 1. Now, minus 1 is the answer for the integral, but we want to find the area. So what we want to think of it is as a value that, yes, the minus tells us that that area of 1 is below, but we want to have 1 unit squared as our solution. Okay, let's have a look at the second one. Okay, number 2. Number 2 wants us to sketch the curves y equals e to the x, so we've done that above, and y equals x squared in this interval. Okay, we can easily do that. So let's draw up ourselves an axis. Got an x, got a y. Let's go e to the x. We know e to the x is going to hit at 0, 1. I'll change the color of that for us. It's going to go along here, up here like this. And that's e to the x. So now we need to think about how y equals x squared would fit on there. So if I'm going to, we're just sketching it, if I'm going to put a 1 there, 1 squared would be 1, 2 squared would give me 4. So my graph would move up like that. Oops. And I'd move up like that. And we want it between -2 and 2, our graph. So put -2 down there. 2 is about up there. We'll pop a 1 in there. And that's a sketch of the curve. It doesn't look great. And if I jump over to Desmos, I'll show you what it probably should look like. It should look like this. My black curve is my e to the x. My red is x squared. But we've got the shape that the x squared sits under e to the x. And if you're not understanding that, then you need to put some values in and have a little bit of a closer look so that you're getting that x squared sits underneath the curve e to the x. And that's part A. Part B wants us to find the area of the region between 0 and 2. So we're in here. And it's finding the area of the region between the curves. So we would like to look at the region in here. So what's really important here is understanding that this curve e to the x is sitting above the x squared. Because what we do when in an interval, so in our interval between 0 and 2, in that interval here, if a curve sits above that whole distance along, which we can see between 0 and 2, our e to the x always sits above x squared, we can put our values to integrate as e to the x minus x squared dx. And that's a nice, simple way. And we've got that written up here. Okay, if you've forgotten, that's what we're doing. Okay, let's jump back down the bottom and answer that. So let's integrate e to the x minus x squared. We need to pop that integral into square brackets because we have a definite upper and lower bound. And let's integrate e to the x. When we integrate e to the x, we just get e to the x. And when I integrate x squared, I'm going to end up with adding 1 to the power and dividing by that power. So I'll end up with e to the x minus x cubed on 3. So let's pop our values in. Now, I know a lot of you are popping these values straight into your calculator and trying to get solutions. I don't want you to do that. I want you to pop the 2 steps down here. It's going to reduce any errors. Let's pop 2 in there. So we're going to get e squared minus 2 cubed on 3. That's our first part. That's the 2. Take away what we get when we pop 0 in. E to the 0 minus 0. I would like you to do that because what a lot of you are doing when you're popping a 0 in, you're just zeroing everything out and popping a 0 in there. So you can see we don't get a 0, we get e to the 0, which is actually 1. So let's get this sorted. E squared minus 2 cubed. 2 2s are 4, 4 2s are 8, so it's 8 over 3. Minus, what have we got here? E to the 0, which is 1, and we don't need that minus. So that minus needs to go through to both of them. And what have we got? Now, e squared minus 8 over 3 minus 1. That's going to be minus 11 over 3. It asked for area, so we're units squared.